Hey guys, so a lot of you reached out and mentioned that you're interested in learning more about the basics of meter and rhythm. And so we're starting a mini video series, and we're going to start from the beginning with common time. Hey guys, so today what we're going to be going over is mostly Western music notation, and as it is currently, we're not going into the history of all of that or even about other cultures' form of notation. So this is going to be mostly what you see in band class and how to be able to do that as well as possible. So in the beginning, to understand the basics of all this, you have to understand meter and rhythm. They're connected, and there's a bit of a catch-22 because you can't understand one without understanding the other. So what we're going to do is I'm going to explain a little bit of meter, and then we're going to go into some rhythm, and then we're going to come back to meter as we continue to learn more. So as you see over here, I'm using Finale to help demonstrate some examples, and here we have a C, and what that C stands for is common time. So common time, as you've probably heard before, is also known as 4/4. This is the most common time signature, or at least it used to be, and it is what most of Western notation is based on. And so we need to understand that in order to understand how to get to rhythm. So the very first thing that we are going to learn about with common time is, and I've got these broken down so that there's one measure for each line, okay? So the first measure, we're going to start with the whole note. And the reason it's called a whole note is because it takes up the whole measure. So that seems to make sense. We are using up the entire measure, so it could be called an entire note, but it's called a whole note because it uses the whole measure. So from there, that's actually how we're going to break down to get all the other notes that we use across all of music. So if we were to split the whole note in half, most of you already know this, and this is going to be a review for a lot of you, but these are really important fundamentals that can be applied to understanding even very difficult music. So if we split this in two, we get two half notes. Now, a lot of people will actually draw the pyramid, and you'll see the whole note is actually at the very top in the middle, and then as you go down, it goes out to the sides. And I actually used to teach it that way as well, but I actually like this better because this is more musical. You always begin on the left-hand side because we read music from left to right, and so it looks more like those croissants before you roll them up that come down a straight line and then go over off to the edge, or like a jagged slice of pizza maybe. But it's not an exact perfect triangle if we're applying it in a musical context like this. So obviously we've got two half notes. If we were to divide again, cut a half note in half, we would get 4 quarter notes. And that's because each quarter note takes up 1/4 or a quarter of the measure. And you can continue to do this to make as many rhythms as you need. Now, for our purposes, we're probably not going to be going much further than 30-second notes, but it's important to know that this can be applied to any rhythm, and that you can always work your way back to a fundamental of the whole note. So the next step beyond quarter notes is eighth notes. And there's going to be 8 eighth notes because it takes up 1/8 of a measure, and so you're going to need 8 of them to fill in the entire measure. And the next level beyond that are 16th notes. And you guessed it, it requires 16 16th notes to fill up the entire measure. We're going to go one more step beyond that, and these are 30-second notes. So that's what you get, obviously, every time when you multiply by a factor of 2, then 16 times 2 is 32, so you get 30-second notes. And I'm just going to hold this down. Okay. So that's a lot of ink. There's a lot going on here. And there's going to be 32 notes that fit into this measure when you use just this one rhythm. Now, all of these rhythms can be interchanged for one another as long as they all equal the space of one whole note. Or if when you add everything up, it equals 1, as in one measure. So you could take a quarter note, or 2 quarter notes, and 4 eighth notes, and because when you add them all up, it equals 1, and I don't know how many of you are good at fractions, but when it equals 1, that's when you get one whole measure, or that's how you know you can fit all of that together in one whole measure of 4/4 or common time. So these are actually the building blocks of Western music notation, and we need to know what these notes are in order to understand how to explain meter, because meter uses what it builds here to go into different forms of time signatures, whether that be 3/4, 6/8, so on and so forth. So what do the numbers in the time signature mean? Well, now that we understand how to break down rhythm from common time, or 4/4, we can look at what these numbers represent. So in the measure of common time, or 4/4, we started with a whole note because that takes up the whole measure. But there are other ways to fill up that measure. And one of those ways is using 4 quarter notes, and it takes 4 of them because one of them is only worth a quarter of the measure. So when we look at these numbers, the top one is going to represent how many, and the bottom one is going to represent of what. So in a measure of 4/4, we have 4 quarter notes, and it's just like fractions. 4/4 equals one whole measure. When you have 4/4, it makes an entire measure. And that's why everything is based on common time, why everything is based on 4/4, because it is what everything else defers to and is related by when you're writing music. So for example, if we wanted to have a measure of 3/4, we would say one complete measure is 3 quarter notes, or 3/4 of a full measure, or 3/4 of a common time or 4/4 measure. Now obviously in 3/4, 3 quarter notes is the entire measure, but it's based on 4/4. And so we would say it's 3/4 of a measure. Just like if you're baking a cake and you're using a cup, a measuring cup, you might only need 3/4 of a cup of flour, but the cup is the standard by which you measure it. It's the same thing here. And as long as you understand fractions, this can be very, very simple. So for example, if we had 5/4, that would mean that we have 5/4 of a measure. The measure would be broken down into fourths or quarter notes, and we would have 5 of them. And so there would be 5 quarter notes to make one measure. So as the bottom number changes, it's representing a difference in the value of note that takes up the measure. So if the bottom number was an 8, like in 6/8, that would mean relative to a measure of 4/4 or common time, we are filling up 6/8 of a measure. And the eighth would be built of eighth notes. So we would have 6/8 notes in a measure to equal that 6/8 of a measure. Now here is where the way I teach this is a little bit different than what you might hear from other educators. They like to teach this bottom number as what gets the beat. but I don't find that practical, and it isn't always true. Now, they will play little games to say that no, that is accurate and count all the way to 6 in a measure of 6/8. But it's not how the music is felt. It's not how the music is conducted. And I'll give a few musical examples coming up of why I don't think that's the best way to think about it. So, what about the beat? The beat is usually defined as the driving pulse of the music, or more realistically, how you would tap your foot along to music you're listening to. In common time, or 4/4, the beat is almost always carried in the quarter note, which is why anything subdivided smaller than a quarter note is beamed together, such as eighth notes and 16th notes. The beams help group notes together into beat structures that, as musicians, we can easily see and perform, and they help us understand how the music should feel. Now, if you feel like the music in the background feels a little off, it's because it is. This group is playing a cover of Watermelon Man by Herbie Hancock, but they're playing it in 17/16. It feels exactly the same as 4/4, but they add one more 16th note at the end of beat 3, right before beat 4, to give it that slightly off feel. This is an example of why I don't like to teach the bottom number of the time signature as what gets the beat, because the audience definitely isn't tapping their foot 17 times every measure, nor are the musicians feeling 17 driving pulses. They're feeling 4 big beats. One of them, beat 3, will feel just a little bit longer, 1/16th note longer to be exact. And if this arrangement were to be written out, it would still use 4 groupings of notes that are all beamed together to indicate exactly where the beats are and how they should be felt. Let's review. Common time, or 4/4, is the standard by which we derive all of our basic rhythms: whole notes, half notes, quarters, eighths, 16ths, and so on. Common time is also the standard by which we understand and relate to every other meter, the top note being how many of something is in a measure, the bottom number representing what the top number is made of. Beats are normally shown in music by how rhythms are beamed together. We'll go more in depth on this in future videos about how to know where the beat is, and I'll give you a hint: check out your tempo markings. In the next video, we will get into dots and tuplets, exactly how to count all these rhythms, and begin exploring the difference between simple duple and compound or triple time signatures. I hope this video was helpful for you in some way, and if you have any questions, comments, or ideas for future videos, leave them down below. And until next time, keep practicing.